I have no idea if the sound's coming through. Nor do I care, thankfully. So I'm just going to set this here. Yeah, I guess I care a little bit if the sound's coming through. Sound? Clip clap? Clip clap sound? Noises? Any noises at all? No? That'll be fine. Internal. Yeah, it should be coming through. It even says it's coming through. All I need is filters, compressor. No, the compressor's totally on. Why is this not giving me the sound I crave? Let's see if it's on the camera somewhere. Shouldn't be. I mean, the camera should be coming up. Okay with that. So, whatever. Oh, that's probably coming through the one thing, so this is probably super loud now. This is coming through these headphones. There we go, that's why. Okay. Yeah, we don't need those on. Where's my marker? There it is. That's not too far out of the way, is it? Yeah, let's do this one. So, card box. We've got index card, lines. It needs to fit into a box. I assume you guys can see this. I guess I'll tilt this a little bit this way, just so it's easier to see. Zoom it in a little bit. There we go. So we've got a box, and it's got cards in it. Let's get another color just for fun. Let's do a box of purple. Cards, this one, this one, this one, this one. Be nice if it had a lid. Doesn't really need a lid, but let's put one on there anyway. So we can close that bad boy. Okay, so that comes down, and of course this can slam shut, so it looks kind of like this. It's closed. Got them all. Now, how tall does this need to be? Because whatever the height of an index card is, A, we need to make sure that this is shorter than A. Because if this isn't shorter than A, we can't get the cards out. At least not easily. Which means that this, whatever this height gap here, cross section of the thing needs to be, this is less than A by some amount, which will equal to B for now. That means that whatever A minus B is needs to be equal to the flange distance here that is somewhat straight in this equation. This will have to be straight. So this is going to have to be A minus B plus, a tiny little fraction of something. That way the cards don't smush, so that when you put the thing down, it doesn't smush the cards. That shouldn't be too hard to manufacture out of paper. big does this thing actually need to be? It needs to be wider than the base of, what is it? It needs to be, this dimension needs to be larger than, it doesn't need to be larger than A. It needs to be larger than B though, because otherwise it'll tip over, especially when the weight of the cards go against it. I don't really know necessarily how to calculate that. If the cards are at a 45-degree angle, if the note cards are at a 45-degree angle, be like this, they're leaning like this, you get pressure in this direction and this direction, but the pressure in that direction is only this way. So, whereas this is up here, and if we assume this is a 45-degree angle, then we have to, so in that case, I mean this is inaccurate because these are going to be leaning off the side, and actually does that give us more or less? I guess that gives us more leverage. Oh, if this goes back all the way, that's not gonna, yeah, because if the cards are leaning back here, like this, when we shut the lid, that's gonna hit them. I don't necessarily know that I want them to do that, because that's gonna leave the lid open when this happens. It comes down like this. What? I like engineering too. Retro Sam. I do this nonsense all the time. This is just the first time I bothered to film, trying to troubleshoot all the problems with it. And I apologize if you messaged that 15 minutes ago. This is mildly engrossing in the way that I'm sure you understand engineering to be. So right now, I'm trying to figure out how to make it so that I can make this whole thing, at least the prototype. I'll probably make a wood version of this thing once I've got the prototype in hand, if the prototype isn't quite fancy enough. I'm trying to make sure that when I close the lid on it, I have a little bit of leeway here for the lid, but I don't want the cards to be pushed when I close the lid, because A, that will put pressure on the lid to stay slightly ajar, which is no good, because I can draw another version of this where it demonstrates what I'm talking about. When it's closed, it's going to push the cards up a little bit. It's going to push them like that, and I don't want the pressure of the cards pushing against the top, and I also don't want the wear and tear of moving the cards to begin with. So the easiest way to do that, I guess there's a couple ways you could do that. You could either make the lip here jut out a little bit so that it doesn't actually, I should probably stop taking these things off. So what do you, I could make this lip actually jut out a little bit to accommodate for the angle that we would expect this to have. And when we draw this out, this would work out to what? You wouldn't need too much of an angle. I'm planning on having enough cards. Let's call it a 30-degree angle. Call that 30 degrees. So, but, so you got a 30-degree jut out the back, which should largely be invisible on account of the way this is going to be designed, although it does make making a paper hinge a little harder. Although maybe not. This actually sort of creates a backrest. So this would be leaning open 60 degrees when this is actually open all the way, which is actually not bad. That's not a terrible thing in and of itself. So you would have a little 30-degree hinge here, just like that. That's actually an interesting idea. But that's probably enough for an initial prototype. We're going to want this thing to be just barely large enough for that. What's that, needs to be greater than B, but maybe less than A, because I don't really want all that many cards in this thing. I mean, how thick are these cards? I mean, I guess I know literally exactly what the dimensions of this are. These are 3 and 5, so the 3 is equal to A and 5. So let's say, just for the sake of argument, that B is equal to 3.5, or the opposite of that, 2.5. So I got a ½ inch of clearance. Let's get a ruler so I can actually get an idea of what I'm talking about. So if you have a 3.5 inch note card, a 3.5 inch note card, a half an inch is more than enough to grab. More than enough to lean out the side. I think that's fine. We can work with that. So B is 2.5. Whatever C is, the dimension on this side just needs to be bigger than 2.5. It just needs to be large enough that it's not tilting on itself, because I don't think the torsional pressure of the cards is going to be so strong as to push this thing over. I don't see that being a problem, but we'll find out if it's a problem later on. Even when it's made out of paper. So less than B is equal to C, or greater than B. So we'll just make that 3 for now. What, 3 inches? Is that wide enough? Yeah, let's make it a little deeper. Let's make it 4. Okay. So that'll let the card sag a little bit. And in fact, actually, the problem with it being 4 is that I'm going to start needing to bolster it. Because if I don't bolster it, obviously, if this is 4 inches deep, and the cards are only 3 inches long, they can lie flat in the container, and that's no good. So I'm going to need at least one divider. And that starts making things weird, because if I'm going to have more than one divider, how thick are these cards? Let's get something or other. If anyone is listening or cares, I would love to know what the audio is like on this. I'm just using the mics on my GX35, which is, it's a nice camera, but it's not that nice. And I can imagine the mics are pretty crappy in a room this echoey. So if I should go plug in an ancillary device, please let me know. This appears to be out of battery. I'm going to set this here. And then go see if I've got another tool I can use for this. Actually, I guess I'm just going to grab a bunch of index cards. What we got here? 1, 2, 3, 4, 5, 6, 7. These are very hard to count. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I want to be able to put 100 cards in this thing. So if this is 18, whatever, we're going to do rounding anyway. What do we got here? We're using all imperial units today. Like good American citizens, we are looking at, there's no way this is going to focus, but it's less than 1/4 of an inch, so it's going to be an inch at most to fit this many cards. So that poses an interesting dilemma, because it almost makes me want to make the box shorter. Because if the box is shorter, then I can make the base smaller. It would make this cutout larger, it would make this cutout an inch, which might look a little ungainly, but then again, I might actually just give it extra support. Let's see what we got here. What would we have to do? We would make this 2.0. We make B equal to 2.0. This would then suddenly have to be equal to, I didn't quite figure out what this was. So this was the gap of A minus B plus a marginal amount, just to make sure that it doesn't chafe. Hello. Hi. Matt's over there. What do we got here? 2 and 3. What was I doing? 3 minus 2 is 1, so 1.1. That's easy enough. I guess that won't look that ungainly. It's just weird because this will be like this. I guess this will be half the height of this thing. Hello? I don't know if you're in frame there. I'm not paying much attention. So, we're making a card box. Engineering is very important, so we have to make sure that we get our lines correct right off the bat. Right now I'm trying to figure out how to get this thing to not tip over, because I want it to be as small as possible, but I also don't want the cards to chafe, because if you just close a box like this, it's going to move the cards like this.
Cause them to flat?
Yeah, and I don't want that.
Can you put a big weight in the bottom? Just like a sheet of metal or something?
I'm trying. No. It's not specifically the That's the problem right now. The thing that I'm trying to solve, although I guess it sort of is, I'm going to make the prototype out of paper. I don't want to have to put weights in it. I want it to be, I want it to work without the properties of the box coming into play. And the only way to do that is to make sure that the cards are standing up far enough, and that I'm not, and that the base of it is wider than the height.
Yeah. Well, additionally, you don't want to make the bottom adhesive, making it adhere to the surface, do you?
No.
Okay.
No. Again, I want this to be a freestanding box where the characteristics of the box don't matter.
Or magnets do.
No.
For magnets.
That would add a characteristic to the box, which I'm not. Maybe in a second version of it, but right now I'm just trying to make it so that I can close the lid without the cards moving and without it influencing the lid to try to pry it back open.
And you say the box itself is going to be made of paper?
Yeah.
Okay. Like cardstock paper?
Yeah.
Or, okay.
That's it. Ew. It's semi-rigid. I don't know if this is more rigid or not. I just get. This is more rigid or not than this stuff. I guess it's a little more rigid. Yeah. I don't know if I have batteries for this thing. Is this even mine? I feel like this isn't mine.
What's the hinge going to be?
This is just paper.
Oh, I thought this was a lid.
It is.
Well, okay, what's hinging then?
This is a cutout. The hinge will just be the edge of it.
Okay. Oh, okay.
It'll just be made out of paper. Let's see, which is a problem because it's not going to lie in one place or the other. So, although actually, I don't know. One of the nice things of having this cutout that will prevent the paper from, the ideal version of this thing. This is the bad version. Is this thing. In the ideal version of this, it will have a cutout like this, so that the note cards sit like this without getting pushed. Which is also nice because it means that it leaves itself open without pushing it all the way down. So if I just make a tape seam, that should be fine there. I really want to see if I'm going to check if I can this thing real quick. This is not where those batteries hide. Where are my batteries? Oh, totally. Okay. Why this died? I just got left on. The battery might have also been upside down, which would be a little strange. Okay, why is this not going in here? There we go. Okay, let me just click this bad boy.
Don't you have two of those?
Of what?
The calipers.
Yeah. Just in case I run out of batteries, I have an extra pair of calipers. I don't think
So
they're
you have
both.
to change batteries.
I don't think they're both mine. I'm pretty sure one of those is Dylan's. Well, that's not zeroed. No, it's zeroed. Okay. Let's go. What do we got here? Zoop. Let's see if that focuses just for fun. There it goes. Okay. Close enough. Versus what I'm going to bet is a little bit, or what I'm going to bet is a little bit more than that, or less than that, I should say. Yeah, just a little bit. Okay, so blue paper is thicker. We got here. So this is basically enough to get started, I think. What am I going to need for cutouts? I'm going to need the following things. I need a base, which is going to have the dimensions of, let's keep doing this in purple just so we have it in purple. And let's make this in focus so it's not out of focus. We need the base of the thing, which is going to be this. Oh, I didn't define this side. This side's going to be, if this is equal to D, this is going to be D plus 1. You shut your mouth. Timer's over there. D plus 0.1, which which is 5.1, so this dimension is going to be 5.1, this one's going to be, I decided on, it just needs to be larger than B, so let's go with 2.2 just to be safe, and then we've got the flaps like this, and these are all equal to B, which is equal to 2, so 2 and 2 and 2 and 2 and 2 and 2 and 2, not to scale. But that should be the base, and then we need this bad boy right here, which is going to be 3 pieces. It's going to be the 2 end caps, which look like this, roughly. Now these are straight. I guess actually, no, that side could be. That might look a little weird if those aren't even. So let's try to redraw this with a bit more perspective. Where is my... There it is. Draw this with, so there's 2 designs this could be. This could either just be a radius, except where this is just notional with a little flap that comes out like this, where this is a 30-degree angle, but this is just a circle of width, what, 2.2, radius 1.1. That's one way to do it, in which case this would need to be how big? It would need to be, what is going to be the easiest way to draw this? Oh, this needs to be 1 inch tall, so this is 1 inch. And if that's 1 inch, we have a 30, 60, 90 triangle, and if I remember my math correctly, and I don't, this should be, if this is a 30-degree side, this is 1/2, this is 1, and this is square root of 2 over 2, I want to say? That's probably wrong, I'm going to look that up. But let's see, so that is, but whatever that is closest to, we'll cross that bridge when we come to it. We have that, we have 2 of these, and then we have, or that's not 2 at all, that's a nightmare. There we go, x2, and then, oh, and then we just need the overarching circle, which is going to be, what was I looking for? I was looking for, I'm sure that I can actually specify this. This radius is equal to 1.1. But if we want to do a piece of paper, oh, there we go, that's the other one I want. I want this, it goes like this, is 5.1, it's the same as this, divided by, I should be using variables the whole way through for this, but I'm doing a bad job of that. And then this needs to be, this is where the math gets slightly more complicated, because I need to know what the, if I don't want to fudge this, which would be very easy to do right now, and I might do anyway, I need this to equal that total distance. And if I do that in one shot, it is going to be, let's draw a larger inset of this. So we know up to the first half of the circle. So let's just do the second half of the circle. This is the hard part. In quotes. I mean, if I was in 8th grade geometry, this would be this is like the most rudimentary state test question you could ask about something like this. It's going to look like this, where this is a 30-degree angle. And this specific dimension is 1 inch. And this is, so we need whatever this dimension is. And in order to get that, what am I missing here? This whole thing is 2.2 tall. So what do we need? That line translates. So this is 1. These are both 1. Whew, okay. The top of this. Matt, do you happen to remember your unit circle correctly?
Well, I just reproduced it there.
Okay, well, I'm going to zoom over there and get that. in view because it will be very necessary to figure this out accurately.
Alright, so are you still thinking about this one? I mean, this is why I drew the...
Yeah.
Okay.
Yeah, we just need the...
Yeah, well, I was getting those links. So if you have that 30 degree, that was a 30 degree triangle you were talking about,
Yes.
which is not the scale over there. Then this is square root of 3 over 2. Definitely.
Square root of 3 over 2,
Yes.
as opposed to 2 over 2.
Correct.
Okay.
Positive.
Alright. Oh, that's right, because it's actually, what is it? It's 1 over 4, 2 over 4, 3, or no, not that. It's the, there's some mathematical way in which it's just 1, 2, 3, 4, because technically when you hit 90 degrees, it's 2 over 2,
Oh, yeah.
because it's 1.
Square root of 4 over 2 equals 1.
Yeah.
That's the finish it out.
Okay, so yeah, and then yeah, square root of 2 over 2 is 45. My bad, math moment. Anyway, thank you, Matt, for remembering your geometry better than I do. Oh, no. Okay, so with that in mind, we know that this triangle, if this is 1, if the 60-degree side is 1, which is what this would be, because this is technically not that. Yeah, this is the 60-degree side, this is the 30-degree side. So this one would be equal to 1 in the refactored version of this. So let's give that its own thing. Let's call that, we can use E yet. So E is there. This triangle is going to be E, and then it's going to be the square root of 3 over 2E and 1 over 2E. Does that seem?
Yeah, that's right. Correct.
All right, good. So with that in mind, let's get the rest of this diagram here still. I have no idea how much this plays or even if there's sound still. Whatever. So if that's true, this triangle goes to both, does it go to both sides just as far? Yes, it does, because it's just equal to whatever the circle is. That seems weird. I think these are equivalent triangles. I think this triangle and this triangle are the same. And this one for that matter. I think there are 3 identical triangles here. That might be wrong. That might be an incorrect intuition, but I think that's true. I'm going to assume it's true until I come up with a reason to think otherwise. But if this is equal to E, so 3, square root of 3 over 2E, 1 half E. So now the problem, of course, being that E is equal to what? Square root of 3 over 2E is equal to 1, which means that E is equal to 2 divided by the square root of 3, which is not a very friendly number, so we're just going to type it. What is it? Square root of 3 divided by 2 is... Nope, that was upside down. That was all wrong. Go. 1.154. E equals 1.155. Let's round it up. So if E is equal to 1.155, we know that this, so then we need, what, 3 over 2E is equal to. Was that going to help us here? If the number we're actually looking for the total of these two, because if we say this is E and this is F, F is going to be equal to twice that, which is E, so it's technically, we need 2E. So 2E is equal to, in truly symbolically monstrous form, 2E is going to be equal to 2.30 something, whatever. What we got here? 2.309 it rounds down to. So that's the extra amount we need, assuming that we need to know what E plus F is, which is equal to 2E because because that ends up being equal to that. Then plus whatever's remaining there. To figure that out, we have another triangle that goes from here to there. The only dimension of that triangle we know is 1, and that goes to 2.2. So why is my math failing me here? This is a radius 1 here. This goes down to there. which isn't quite all the way. It's not even halfway to that triangle, because this, oh no, we do know that, my bad, because we know what f is. And it's going to be equal to 1/2 f, which is equal to 1/2 of e, and 1/2 of e is equal to, what do we have? So this is equal to 1/2 of e, this is e divided by 2. So we just need to know what 2.2 minus e divided by 2 is. Minus e divided by 2, and that is equal to 5.8 or 0.58. So this is equal to 0.58, which seems small. That can't be right. Oh, that's e divided by 2. That's not, so I didn't subtract them yet. My bad. Okay. So 577 minus is 1 point, there we go, that sounds more accurate, 1.62. So that's that distance, which means that we now have enough information about this particular who's what's it to figure out, what was I doing? I was figuring out what portion of the circle is not part of this equation. In order to do that, we need to know what the arc of the remaining circle is. And in order to know the arc of the remaining circle, we need to know, this is going to be a square, this right here is a square, this side is equal to this side. See, this is both 1.62, which means that this is equal to, let's subtract again, 2.2, oh, that ends up just being that again. Oh, there's probably an identity property there I missed, because this is 0.58, which is e divided by 2. That makes sense, because this is 2, and it's a square. My bad. So this is, although, is that accurate? It seems weird that that'd be true, but whatever. Okay, so 0.58, so we now know this, and what we need is the square. Did I screw this up? Am I calculating the wrong angle? I'm calculating the wrong angle. I need this angle right here. But this is a square. So of course this is going to be 45 degrees. That doesn't make sense. No, this isn't a square. This can't be a square, because this is only one high. And this is too high. That's impossible. I screwed up here. This is not a square. What is it though? So it's equal to 1. I have that right there. What the fuck am I doing? 1. Okay. I wrote that shit down. It's on the other side. This is some A equals A bullshit going on here. 1.62. Now we need to know what the angle of this is. We need to know this angle. This is the final step in figuring this out. That angle is, we have 1 and 1.62. So we have the tangent side of this equation. And the tangential side of this equation is going to be 1 divided by 1.62 in some capacity. It has been so long since I've done geometry, I'm going to forget which way it is. But luckily,
Tangent theta equals opposite over adjacent.
yeah, opposite over adjacent. Yeah, I got that part of it. But now we need what? So you just throw it back in. What? Tangent of theta. I assume Google knows how to do this shit. So we're going to type in tangent of what do we got here? Tangent of theta, which means that it's just theta. This is equal to the tangent minus 1 of okay. I typed in the hyperbolic function. It's not really what I'm looking for. My bad. They call that arctan, don't they? It's been a while. Yeah, 0.553 radians, which is 0.553 7 degrees, which is more detailed than I can possibly cut at. So we should probably just round that to 32. And that is the side that we are missing, because that is this bit right here. This is 32 degrees. So that's the part of the circle we don't have to worry about. The remaining part of the circle, if this is a 90 degree, and I'm reasonably sure that's true, is going to be 90 divided by or minus 32, which if my math is correct, and it never is, that's 58. So this is 58 degrees. So now we need to know what 58 degrees of a 2.2 rate, am I sure that's still the right number? It's not. Oh no, the way that I was going to calculate this, it was fine. I'm not doing this anymore. I don't have to worry about that. 1.1 is 2.2. Yes, because this is, no, this is the, fuck, I did this wrong. 2.2 is, I transferred it from being a diameter to a radius. It only needs to be a diameter. Shit. So if that's 2.1, we can make life a lot simpler. No, we can't. Yeah, we can. We can skew all of this math by just bringing this curve up all the way so that it just goes like this. So we can skew all this math on the second go around. Because this is going to be so close, or this, that's the exact problem, is that I wrote this in the wrong place. This is 1.1. This is also why you do symbolic manipulation and then type in the numbers so that you don't do shit like this. 1.1, if this is 1.1 and this is supposed to be 1, we can just round that up and that makes life a lot simpler for everybody. So now we only have 2 pieces to cut. The new piece we have to cut looks a whole lot like that, which is relatively straightforward. This is 2.2. And if this goes to 1.1, that means that this is 1.1, and that is still going to be a 30, 60, 90 degree triangle, which means that we just go over here and we plug back in for what E is equal to. We know this one, so we know that that is equal to 1.1 now. So all we need to do is slowly modify everything here. We're going to actually just erase this and try that again because we don't need F anymore because that's its own extemporaneous bullshit that we don't have to calculate. So we're going to go with E is equal to 3 what am I doing? Quarter 3 to divided by or what is it? I need this to equal out to, if this is 1.1, this has to equal out to 1.1. So there we go. Okay, 1.1. And so that's what, 2.2 divided by the square root of 3 is equal to E. And that is, this is necessary, right? Yeah, this is necessary. 3.1, what the hell am I typing in? 2.2 divided by the square root of 3 is 1.27. So this is equal to 1.27. No, that's what E is equal to, my bad. This is technically equal to 1.27, which is necessary, we need that number. So we'll type that in there. And then we will figure out what this one is. And it's just equal to half of E, so that's easy. That's 1.27 divided by 2 is 0.63. Now, is this, having screwed every other part of this equation up, is that accurate? Is that just up to the center line here? No. That would be a 45 degree angle. There's some amount missing here. But thankfully we don't have to worry about that because this is going to be an inscribed triangle that's only symbolically there. It's really fine that it is a 45 degree angle because we know all the rest of the math there. If this is a 45 degree angle, then we just need the radius, and the radius is 1.1 this time, as opposed to 2.2. So this is 1.1. So now the total, our sum of things, this is bad math, but it's fine. The thing we need is, we need a quarter of this circle. A quarter of that circle is 1. If the whole perimeter deal is 2 pi r, then we have 2 times pi times 1.1 is equal to, that's
for a whole circle.
That's the whole circle, yep. 7 seemed a little high. So we divide that by 4 and we get 1.72. So 1.73, we'll round it up, plus 1.1 plus 0.63 plus 1.27. And that is equal to 1.73 plus 1.1 plus 0.63 plus 1.27. It's 4.73 for the total. So that is that curvy piece if we curve it all around, and there's no reason not to, because we can do that in one contiguous piece. So, and then we just need this thing, which we just did all the dimensions for, so that's not hard. In fact, we figured them out by doing the rest of this. So we need this, we need 2 of these pieces. I guess let's redraw this again. So we need 1, let's get a third color just for fun. We need 1 of these, 2 of these, and then we're going to need 1 long piece that looks something like this, which we'll segment into bits as necessary, but we can fold those over. Right now we're just cutting things. This needs to be equivalent to the length, or the width rather. This is absolutely not to scale or proportion. 5.1, so it needs to be equal to the width of the whole box. And the length of it is going to be 4.73, which seems a little strange, but there you go. I don't know why I wrote a 2 there, that was bad. 4.73, which I can't cut that precisely, so we're going to round. In any case, we need 1 of those. So 1x, Okay, there we go. Has anyone said anything? Of course not. All right, so with that in mind, let's cut something. Is that not showing everything?
Not at all.
That's fine. Okay, I'm going to get a drink, and then we'll be back over here. little bit closer just so that you guys can hear, since this camera, again, probably not terribly precise with the microphone. Love this thing to death otherwise, but it does have problems, so. Yep, there we go. That will do. I'll pull this back just a little bit. All right. So, making an index card box, we did some math, tried to make a box head or a clamp down mechanism that if we're making the whole thing out of paper, it doesn't shuffle the note cards because I want them to just sit flat. In order to do that, we're making a little lip on the box, which is not actually like that anymore. The lip of the box looks like this. And that also is nice because it gives it a little wedge to sit on when it is open, which will be nice when it's made out of paper. But we just got done doing all the dimensions for it, which involved using a unit circle. Thanks again, Matt. And we are pretty much ready to cut this stupid thing out. We need one long piece for the taper over the top of the box. Then we need 2 guides for the circle. And then we need the box proper. So let's cut all this bullshit out. Actually, let's hop this thing up on here. Put this on the desk. Maybe not that far. That'll do. Alright. That should do the trick. I need more sheets of paper than this. Peppered the temptation to just cut this thing out of whatever and hope for the best the first time is actually partially laudable in sort of the way that I do these things a lot of the time, but occasionally it's fun to be more rigorous about it, particularly when you have the potential pressure of no one watching on the internet. What was I about to do? I was about to cut those out. I should probably have a picture of them over here. Yeah, we can draw them out, that's fine. And we'll use this because it's wasteful. Actually, we'll use one of the index cards that we're working with, and we'll focus this just to make sure it's actually in focus. And what do we got? Okay, so we need one of the following. We need this little box like this. Drawing it out again will also help just because it makes sure that the design makes sense in my head. Given that I already made like 5 mistakes on the road here, it would make sense that I would screw up again at some point. So the width of the box is 2.2, or the depth of the box is 2.2, the width of the box is 5.1, and all of these leaflets should be 2 inches, I decided, so that I have 1 inch of leeway to grab the cards, which is nice. And then we have, what do we need? We need 2 guide rails for the arc of the cover, and those look, oh, that's an absolutely atrocious circle. Now let's pull out the heavy machinery for this, just because we've got it. Let's grab one of these bad boys. We're going to use this in a minute anyway, so it's not entirely indulgent to take this out. Oh, come on. There we go. Let's make a tiny little circle with this bad boy. Go. I got one of those. That's great. No, it's stuck in there. Whatever. I'll get another pencil. Okay, so we got this. This part is technically notional. It doesn't actually exist because it goes up to here. This comes around like that. And this in total, what were the dimensions on this? This part is 2.2. This is the depth of the box. And then this leads up to, this is a 1.1 inch high surface. The part that we need, the only other dimension we need for figuring this out is half of E here and half of E there was what? 0.63. So this part is 0.63, which is more precise than we're going to be able to cut, but that's fine. And then this is a 30-degree angle. So we just need to know that this is 30 degrees, and that should be fine. So we need 2 of these. And then we need 1 overarching big old dumb piece like this, which once again I'm not drawing to scale and that's going to throw me off. So let's make this one a little more proportional the way it's supposed to be. This looks like this. This is the width of the box plus the over curve, and the over curve worked out to a sum of 4.73. So now we have all of this on the card, which is right here, and maybe this will focus, maybe it won't. Oh, there it goes. Cool. All right. So that's what it looks like. And now we get back to it. Now for the fun part. Drawing. So let's take this sheet of paper. Let's make the big stupid one first. Actually, no. Let's make this slack here first. So what do we got? We got one of these. We need this to be 5.1 wide. 5.1 on this scale. This is 5, 1, 2, 3, 4, 5.1. 5.1 is right there, so it'll be on the inside of that curve. The inside of that curve is roughly right. Oh shit, I lost it. Okay, that's why we have 2 rulers, so that we can do these both at the same time. I should be using this ruler anyway, it's more graduated. So we're going to use this one instead. This is 1, 2, 5, 5. This would be a half, an eighth, or a half, a quarter, an eighth, so a tenth is somewhere right around there. And then we just draw that all the way up, I believe. Do we want to mark the other side of the paper and run it across? I don't see why not. Line that bad boy up like this, and then go like that. Okay, and then we just bring that across. Probably zoom this in a little bit just for fun. Just a little bit more. Yeah, that's fine. That'll do. Okay, so what do? First, we test to make sure that this is actually... oh, I guess this does have lines on it. But they're not precise enough, are they? This is a half. I've never used this thing before. I just got it. I didn't realize that they sold devices like this, so I just got into it. Actually, yeah, whatever. Let's use this thing. That seems more fun. We need this to be equal to 5.1, which is somewhere around there. If we do this all the way across, it's giving me a headache to see the grid underneath not aligned, so let's align the grid underneath like this. If you find this boring, please turn it off. You're under no obligation to spend your New Year's Eve holiday watching me do this. But if you are, again, thank you and welcome. What is this? So this is 1/2, 5/8. Sure, fuck it, let's see if this works. Okay. That looks uneven to me, but let's check. Looks pretty much right. This side looks like it tapered off though, but it didn't. Weird. Okay. I just did a bad job marking it, which is not surprising. So that's this.
You only have 1 piece of paper too, right?
Yeah, so that's fine. And this one needs to be, where's my note card? 4.73. So we'll do this, and we will cut this to 4.73 is about a quarter, just shy of a quarter. Let's line this up so it's not driving me crazy. There we go, like 4.73 looks roughly like this. Just below the cusp on both sides. That's good enough for going to work. There we go. Okay, this doesn't look straight to me, but if the math says it is, I will trust it. Yep, that's exactly, and this is exactly. So, all right. And we'll cut out these little, actually, yeah, let's do the easy one first. Let's do this. This will all fit on one sheet of paper, right? 5.122. God damn it, this will not fit on one sheet of paper. 9.1. So, yeah, well, what the hell am I talking about? The other direction is the one that's hard. 2.2 is 6.2, 6.2, 9.1. Will definitely fit on a sheet of paper. Let's cut the long dimension first. That looks, oh, I can't use this for that. That's a bummer. Yeah, I can. I just flip it around. What's 9.1 minus 11? 11 minus 9.1 is 2.9. No, it's not. It's 1.9. There we go. 1.9. So this is going to go like this. Just barely not touching what 1.9 versus 1.875 is 3/8, 7/8 rather. So it's very nearly there. We'll just put it very slightly over the line right there. Yep, there we go. Oh, god damn it. I don't like how that moves. There's no way that's straight. That definitely moved. I need to hold this thing down when I'm using it. Let's measure it anyway. The measuring is just so delusional I can't tell.
Hold it while you cut, is that what you're saying?
No, I can do it. It'll be alright. But it keeps sliding. I mean, that's basically as even as I could reasonably expect it to be. So I don't necessarily, I mean, this one should be 8 point. I guess I didn't measure the paper itself first. I should have measured the paper first just to make sure that it was accurate. But in any case, there we go. Just a touch. That's definitely the shorter side. This is 8.5, so this side needs to become 6.2. 8.5 minus 6.2. Sorry, is 2.3. That is 2.3 is closest to 3.75. No, it's closest to 3. It's closest to 2.5, 3.75. Oh, wow, those are very close to each other. 25, 375, 3. So it's basically between those two, which is very uncomfortable. 33. It's closer to a quarter than it is to 3/8. Okay, closer to a quarter than 3/8. 1, 2. Wait a minute. How is this graduated? That's a 2. Are there 5 steps between those? Am I missing something here? No, that can't be right. It's marked twice. And I've only used the 1/8 inch stuff, so that makes sense. Okay, well, in that case, I suppose I will. Now let's bring the camera down a little farther so you don't see. I guess I'm staring at the back of my head so much. Zoop. Da 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 da. There we go. That should make for slightly better watching. My head's still totally cut off, but that's fine. I need this to be slightly closer to a quarter than it is to 3/8. So there we go. That's probably about right. We're going to slice before we think about it too hard. There we go. Okay, so this should now be 6.2 on a side. 6.2 on a side looks something like that is, yeah, that's about a quarter, which is right. And then this is about a quarter, which is about right. And then this is 9.1. 9.1, there we go, that is also correct. And is this very slightly more than 9, or like less than 1/8? Yes, it is. Okay, so now we just got to do an end cut of 2 on each side, which unfortunately means I have to use scissors, which I don't like doing, because scissors suck. But I do have 2 pairs of them. So let's get to it. How do we cut a square out of this? We're gonna have to use this straight edge because this is an odd number, odd shape. So let's just do some of this. Let's take our best guess at how far in we have to be for each of these. We'll line this up on paper so that it's mostly even, and then we will take our best guess at where 2 inches is on both sides and put a tick mark going horizontally so that we know that this is a reference to the vertical dimension, and we will go like this. There we go, and we'll do it like this. Something like that. Oh, that was a terrible one. Okay, that was way too fat. So on the upper end of that tick mark. There we go. Okay, now we do this the other direction. The other direction. We now know that this is the correct dimension. I guess I'll zoom in on this a bunch so you guys can actually see what the hell I'm doing. So in this, because we measured it in this direction already and we made a best guess about how far to one side it needed to be, and it actually turned out to be a very good guess on this side. I made a horizontal tick here so that now when we do this in the other direction, we know how far down it needs to be. So we just line it up now and we make a little cross. So that exact dot right there is the point. It's the center point that we have to worry about. And over here we missed by a little bit, but that's okay. So it looks a little bit more like just the side of a box, but I have no idea if you guys can see that. And it's coming through okay. So as far as this thing zooms, yes it is, okay. So that's, I guess I'll just show it to you guys once I'm done. But we then line this up again over here, and it goes like, no, this is the wrong dimension. There we go, this is the dimension we're looking for. We're looking for 2, oh, I missed it by quite a bit over here. So these don't even line up, but I'll explain that once we get to it. And then we got these, and they go like this. Okay, so the way that this looks, I guess it was actually reasonably close to begin with. So this one was reasonably close, measuring both directions. The point where those 2 intersect is what we're looking for. Same here. These I missed on my guess a little bit, but that's okay. We just have to make sure that the point of each of the cutouts matches that dot, and we will go from there. Okay. All right, so there we go. Now we're going to cut this. We would draw lines, and probably should, on account of needing to use scissors, which is not fun. Or we could use an X-Acto knife, which I think we're going to do. So if these are lined up, then we should be okay. Because these are supposed to be the same distance both ways, so we're just going to go like this. We're going to start, let's do it on the safer side first, just so that if I screw it up, I can throw it all away immediately. We're going to line these up like so, like that, and like that, and then we are going to just start at the middle and go like this. There we go. We'll do the same thing over here. We'll start at the middle point, which appears to be right there. Go like this. Did I get that right? Yeah, close enough for government work, and then we'll go like this, go here and there. Line these up, start at the center point here, and go like this. And while we're here, we'll do it on this side. And then we'll line this up over here. And this is more annoying to look at on that side, so we're going to bring it over there so we can see both of the lines. We're going to mark this off right there where they intersect, going across, and then we're going to come over here and do the same thing over here. And then we will do the same thing over on this side. That will be a mark there and a mark there, so we'll line these up. And we will that. There we go. Okay. Oop, I did not cut that rib. Just trace that again. There we go. That will do. Okay, so now we just need to fold this bad boy up. That looks like it's out of focus. I don't know if it is. There we go. Okay. So now the only piece we need is the only piece we have left to produce is 2 of those. So we're going to do that now. So what do we need? We need a total shank of 1.1 by 2.83, which is, neither of those are great numbers. I'm not a huge fan of either of those, but they will both fit on this sheet right here probably. How wide is this thing? This thing is, oh yeah, that's way more than wide enough. This to be what? Actually, will they fit here? No, not that small. Maybe a little bit larger than that. I'm going to go with this to accomplish that. We need 1.1. 1.1 looks roughly like what? Where does this cut exactly on this? If I line this up perfectly here, and I line this up what appears to be perfectly here, what does that cut? Absolutely nothing. Okay, so if this is actually, oh, it is now. That actually lines up reasonably close to, I have no idea how to make this work. There we go. And actually, it's reasonably close to dead on there. That's nice. Okay, so, oh, what do we want to do here? We want to cut this like this. These are inches, if I'm not mistaken. They are. We need this to be 1/8 off. So 1/8 off is about that much, just like that. And we need to pin this on this. Oh shit! Yeah, this is going to be hard. Oh, these are marked down here, and they're marked over here. Okay, we'll just use this. So we need this to be here. And then we need, sorry about that, we're actually going to line it up with the inch marker so that we can line it up over here. Inch markers work out to 1 is right there. So we're looking for this marker right here. And unfortunately, this Fiskars is not quite long enough to do this in this direction, so we're going to have to turn it and do it over here, which is fine. That's why it's important to get tools that line up with each other. So what, this is 29, we'll just line it up with this, and then we will line it up with that, right on the cusp. And then we'll do the same thing across to the other side like this, and then we will remember to hold this down, and we'll go like this. And then we will notice that it doesn't actually cut all the way to the end, so we might have to cut this a little bit. But thankfully, the total we have to deal with is a little over 6 inches, so we can be imprecise about that. And we can just rip that off. This is the base. Okay, so there we go. All right, just double check, make sure this is actually, oh no, I picked the wrong one to throw away. My bad. This is the one we gotta throw away. Yes, this is 1 inch. 1.1 inches to be precise. So now 2.87 is dangerously close to 2.875, so we're just going to cut this to 2 7/8 twice. And that is going to involve it being on this side again. So we're going to line this up with 2.78. We're going to line this up backwards this time. We're going to line up this one, and then we're going to line up this one right there. There we go. And then we'll push the paper into 2.78 just to see if this is an easier way to do this. No, that's backwards. We need this to jut out by 2.78. So this might be a little messy. If now, let's pull this forward a little bit. Let's pull this to right here, and then we will put that to right there. Yep, there we go. There we go. That's perfect. We'll slide this bad boy in like this, maybe. This isn't gonna take it. Yeah, whatever. Okay, so we'll line this up for 2 inches, just like that, and then we align the cutter like this. And over there, and then we check one more time to make sure everything didn't move. It doesn't appear to, and we go like that. Okay. And for this next one, we're going to do this the cheesy way and just line these up and pretend that they are both the same size. We'll line this up on the inch mark just so they're not too far off. But in essence, we're just going to we're just going to line these up and hack them both off. Although actually that's harder said than done on this side, honestly. Oh, I guess I could just do this. Just duck the paper right there. Make sure it's aligned on the side and then go like this. Okay, there we go. So now we have 2 pieces of paper that are how close to each other? Pretty dang close. There's a very, very slight amount of overflow, and there's no way this thing's going to focus this close. I'd have to like put it in my hand or something. There we go. There's a very, very, very slight amount of overflow on this thing. One's very slightly longer, and I'm actually going to clip that little bit there just because I don't like it. Actually, this will probably go, no, this part will go away because I'm going to, yeah, that part will go away when I cut into the rest of this. So now we need to cut a circle in both, and we're going to do this the economical and cheesy way. Let's unfocus that thing. We're going to do this the super cheese ball way and cut them both at the same time. So we're going to line these up just like this. Or not. Maybe we're not going to do that because they don't actually line up that well. Nah, they line up okay. I don't know why I'm getting these hallucinations. This thing is not actually lining up as well as it is. And then we are going to make a protractor circle. Stop doing that. A protractor circle that goes from here. We'll take a best educated guess for the first pass. It needs to come up a little bit like this, and then we do a circle. Okay, there we go. That gives us the degree of correction, which is not much, and we go back around the other way. And in fact, they are so close to each other, I'm tempted not to make a correction at all because I'm not that precise. But I'm going to give it a shot anyway. So let's try and do that again, going like this. Nope, that was even worse. All right, whatever. We're just going to cut this and pretend that it works. Okay, so this one requires a slightly steadier hand than the other one, which is a shame because I'm cutting 2 pieces of paper and I'm very bad at this. I guess I can spin it around with the blade, but you know, I want to make it feel bespoke. And the easiest way to do that is to make it look bad. So There we go. Close enough. All right. And then we just need a 30-degree angle that juts out 0.63, or a 60-degree angle that juts out from the one side. In order to do that, we're going to pull out our hot protractor slash triangle. I refuse to call these squares the way engineers do, because engineers are monsters. Naming things incorrectly. This is clearly not a square. This is clearly a triangle. Oh, son of a... I guess I can just turn the paper over. It's the same on both sides. So we're going to do this. We're going to... There we go. This is going to be pretty uneven by the time I'm done, I'm pretty sure. There it is. Yes, we'll do that. We'll throw this. This says see-through, but it looks like it says Cthulhu every time I look at it. Okay, there we go. That's more than good enough for me. Let's cut like this. There we go. That's close enough for the second. Ghost for the second. So there we go. All right. Well, that should do it. Actually, let's cut that rough edge off there real quick, just so it doesn't look quite so stupid and terrible. Just like that. Okay. So there we go. Now we have 3 pieces. And they will all fit together marvelously. Let's get this other shit out of here. I don't know if I have an 18+ warning on this. I think I do. It's my continuous stream, so it should definitely have one. Yeah, let's fold this thing up and get this done with. Alright, so we're going to fold this one like this. Fold this one like this, out to there and there. And fold this one this way, like this. Now we're going to fold this one in like this. Perfect. Alright. I'll do this a little bit. Tape it up. And for the sake of aesthetics, we're going to tape it on the outside so that everybody knows all the work we did. There's blue painter's tape because I don't like masking tape, and Scotch tape is stupid. There we go. Pop that corner a little bit. This. That. Throw this around. I would apologize for not providing more color commentary during all of this, but as you all know, the joy of creation supersedes that of Twitch-style banter, so you're welcome. I guess I could describe what I'm building this box for. It's going to hold index cards that contain important information like what I should do on Tuesday or Thursday or other days of the week like Sunday, Monday, Wednesday.
So you're just going to have a card labeled Thursday?
Yeah, I'll have a card labeled. Yep. And it'll be easy to access and won't chafe.
That's key.
That is very important.
Wait a second, when do the cards go into the card box?
I don't know. I haven't thought that far ahead. Anyway, so that's the base. Oh, what do we got here? We got this over business. All right, so this is the most weirdest one. I don't know if this is where we find out if my Pythagorean mathematics pay off. This is the width side. Yes, it is. So this needs to fold in such a way that it matches the curvature of this. So this is the moment of truth. This is when I find out whether or not I should have just stayed home from school instead of going to math class, which to date I consider to basically be a wash. I have intended to make some kind of statement about that, and I don't think I ever have on the podcast. Maybe I will get around to it this season. Who knows? Just depends on how mad I am. Alright, there we go. That should be curvy enough for this. Not sure how we want to upholster this yet, but I do just want to make sure that it actually conforms to the shape we were given. I mean, if worse comes to worse, I just cut it, which is what I would normally do with a prototype, but I felt like doing I felt like being a little more rigorous on this one for no obvious reason. Normally I would just cut off the slack. Okay, and then, oh, actually no, I guess we know where to fold it. We need to fold it at 0.63 plus. Oh, that probably ruined everything. Oh, whatever. You guys weren't paying attention anyway. That should take care of it at what? 0.63 plus 1.27. There we go. That's the number I'm looking for. Jesus, could not find it. All right, so now we're going to go like this, put it back down, zoom it back out. All for you fine folks at home. All right. 1.27 is basically 1.25, so let's fold it. Let's throw this right here. Let's put this pencil like this. Come on, 1.25. 1/4 is, this is a half, this is a quarter. Once again, that's a quarter, that's a half, that's a quarter, and then we're just going to mark this all the way at the absolute edge, like that, and then we will fold it over. And we'll match this up here just to make sure these look reasonably close to each other, and they do. And now we will fold them up. The over, lovingly written on the top so we never forget all the fun we had here today. Does this match up? Sure does, all right. Thanks, math.
Congratulations.
Sometimes it's useful. Most of the time, not useful. Now how am I going to tape this, though, is the problem. Poorly. So, let's get this going. Let's throw this on here. It's okay if the tape leans off a little bit. We did not measure how much tape we were going to need, which if we were manufacturing these boxes would be important information. But thankfully, the Machination Log is an aggressively non-profit organization, so we're not worried about things like capitalizing. Oh, I guess that would sort of fit there, wouldn't it? I guess we can actually sort of move the tape up. This is the reason why I use painter's tape, is so that I can just peel it off like that. I guess we can actually sort of lean this up a little bit. So that when we do, what is the direction? This needs to go in this direction, just like that. Right there. Cool, alright. Then we pull this up and we throw this down like that, and we fold this over like we meant it. Yeah, there we go. A perfect seam. I have no idea if this is still in focus. I guess it kind of looks in focus. Okay, and then we just fold this bad boy on the inside and pretend that cut didn't happen. We do the same thing over here. Just an identical piece of work. Fold this over like that, get this lined up a little bit, throw this like that. This bad boy over like that. Oh, how did I fold it on this side? We folded this side up first, and then we folded this. It's very important to get symmetry in your household craft projects when you least expect it. There we go. Fold that over. Yep, just like that. Okay. Now we just have to figure out how to... I didn't build in a mechanism for actually lifting the top of the box, which is fine. I can just cut a little hole right there. How do I want to tape this? I'm going to tape this side on the inside because this is going to look so bad from the outside. I feel ashamed to have this box in public. This side also doesn't matter as much just because the cards aren't going to be leaning against it. You know what, let's put this on the one side first. That would be smart. Come on, you can do it. There we go. Got your exciting little inseam, which is very reminiscent of sewing. With the little slatted fold overs. I forget what those are called. Darts? There we go. They're called darts. Grand total one person watching. Who's the last straggler? Who's bothering to waste their perfectly lovely 80-degree Monday down here in Florida. Watching me inside build a box for cards. And then this should fit like this roughly, and then we're just going to tape this a little bit, and off we go. Let's cut the tape bullshit off of that. There we go, just like that. Cut this off so it looks a little bit nicer. Not too much nicer though. Attract thieves. There we go. Alright, now we just got to tape the back so that it stays on. So this goes like that. And within tolerances, I would say that's a card box. No, that wasn't terribly in focus, was it? Put some index cards in there. Will this fall over immediately? Nope. And it won't chafe the cards because we got this little thing in the back. Although I will say it does not need to be this tall because I forgot that the cards are hanging at an angle, and thanks to the ever-present unit circle that rules our entire life over here, they're not 3 inches tall when they're sitting in the box. Yeah, I need a little flip-up mechanism here, which that should be easy enough to do. What's this? Oh, it's bending now that the cards are in there. Oh, that's a bummer. Oh well. Or you could just stuff it in like this. On account of the tolerances not being quite what they should be. Alright, let's just put a stupid little pull tab on this thing and call it a day. Alright, that'll do. I'm shutting this shit off. Everybody have a nice day.